In problem 642, you have an elevator that starts from rest and raises to a point 25 meters above the ground, where its velocity is then 3 meters per second. The mass of the elevator is 1,200 kilograms, and again we can start with our conservation of energy equation. The initial potential energy is 0 because you can pick the reference for potential energy to be on the ground or wherever the elevator starts. Since the elevator is at rest initially, this is also 0. The kinetic energy initially is also 0. The work is broken up into two parts for this problem because you have both a lifting mechanism and a frictional component. So you have the force due to friction, which is given to be 500 newtons, and then you have the work done by the lifting mechanism that causes it to raise up. So let's break the work up into two parts. One of them is the work done by the lifting mechanism, which we'll just say is W sub L. And that is what we're trying to find in this problem. The work done by friction, you can just use that the work is the displacement times the force times the cosine between the displacement and the force. And in this case right here, the theta, the angle between the frictional force and the displacement, is, like the last problem, 180 degrees. On this side of the equation, we've completed all of that. We got two zeros and then also two terms from the work. The potential energy is mgh, or h is actually going to be equal to the 25 meters above the ground. So this is also equal to h. It's not only the displacement that you use for the work, but it's also the height above the ground that you would use for gravitational potential energy. Using 1/2 mv final squared for the kinetic energy will then allow us to solve for the work done by the lifting mechanism. So move this to the other side and then plug in all of your values to find the work done by the lifting mechanism in joules.